Okay, so this is Mr. Ellis, and we're going to talk about the chemistry section. I've been kind of late on this, so I'm going to kind of move it up right here. Let's see, matter. Okay, now matter. This was our first section we did, 8.P.1.1. Matter. It's anything that has mass and volume. A lot of this should be reviewed from sixth grade. Everything is made of matter. The air, liquid, water. You talked about the four states of matter, probably in sixth grade. Solids where the atoms are closer together. They're always moving and vibrating. You add more energy to it, they actually expand, move faster, and go away from each other. So that's what happens when something melts. When you add heat to a block of ice, the atoms actually start moving faster and faster, and they move away from each other, and they form liquid. And then, of course, keep adding more heat. That liquid will boil off, and it'll evaporate and become gas because it's moving faster when you heat it, and it's moving farther and farther apart. Now, we're not going to talk that much about plasma because that's what's in the sun. There's a little picture right here. Shows you all the different way it looks. And I know they like doing EOG questions where they'll show you a picture. You got to tell me which one is the solid, the liquid, or the gas. Now, an element. An element is a pure substance that cannot be broken down into simpler substances by ordinary chemical means. You got a periodic table. We've been working on that. There are 118 elements. 92 of them are naturally found in nature. The ones after 92, they are ones that we call synthetic. The word synthetic means it's man-made. It's made in a lab. And again, like I said, there's 118 right now. Your periodic table that I gave you from the state of North Carolina only has 112. Now, a molecule. A molecule is when we have two or more of these atoms that are held together by chemical bonds. For instance, if I had two oxygen molecules, because they're actually what we call diatomic, they actually travel in pairs. Nitrogen travels in pairs. That's the gases that are in the atmosphere and the air. Well, they're molecules because they're two or more atoms. Now, then we have compounds. Compounds is when I have two atoms that are different elements. So I could have a molecule of water and a compound of water. Okay, so compounds are different elements put together. A molecule could be different compounds put together, or it could be the same element put together. Different elements put together. So a compound is when I add two or more elements. Sodium chloride is salt. Sodium the Na, chlorine is the Cl. Okay. Water is a compound because it has two hydrogens and one oxygen. It has two different elements. Now, another thing you know about compounds is that they're chemically formed. So if you see a question that asks you about compounds, you're going to choose a choice that talks about chemically. Now, if it's chemically in the question, which one is formed chemically together, then you're going to choose compound. And it's easy to remember because they both begin with a C. Now, a mixture is when we join them physically. It's not chemically. A mixture you can actually take apart easier. It's when we mix things up. Salt water is an example of a mixture. Air is an example of a mixture. Lemonade, your coffee, sweet tea, sodas, those are mixtures. Okay, there's two types of mixtures. The first one is heterogeneous. Heterogeneous is hetero means different. See what it is, you can actually see the differences. A salad. If you have a tossed salad, you'd have tomatoes and cucumbers and croutons and cheese and ham. You can all take it apart and you can see the differences. Pizza is a heterogeneous mixture because you can see the different toppings. Trail mix, that's a heterogeneous because you can actually see and distinguish the differences. Now the opposite of that is called homogeneous. Homo means the same. So homogeneous means they kind of look the same. Milk is homogeneous. And then when you look at milk, it says it's been homogenized because milk is nothing more than water and fat put together. And that's why when milk goes bad, all the fat chunks up and it separates. Homogeneous, they actually mix it up so you can't tell that it actually has fat in it. So homogeneous means the same. Vinegar is one of the questions. Air is homogeneous because you really can't see the difference in the molecules in the air. Lemonade's homogeneous, and a lot of solutions where you dissolve something into some kind of liquid, that's usually homogeneous. Okay, there's your picture of what it kind of looks like. We're not going to really worry about that too much. Now, we've been talking about atoms. Those are basic building blocks of most of the matter around us. They're the smallest particle of every element, and it has the properties of that element. There are 112 different types of atoms in the world, in the universe. Okay, an atom has three parts. Inside of its nucleus, it has protons and neutrons. Protons are the positively charged. They tell you how many. The protons are the positively charged. When you look at periodic table and you see the number 2 for helium, that means it has 2 protons. If I look and find hydrogen, it's number 1 atomic number. That means it has 1 proton. So the periodic table actually tells you how many protons you have. Now with neutrons, those are inside. They kind of neutral. They don't have any charge, positive or negative whatsoever. Now, to find out the number of neutrons, you would actually take the atomic mass and subtract the atomic number. So the decimal that's in your periodic table minus the whole number. That would give you how many neutrons. Sometimes it's the same as the protons, sometimes it's a little bit higher or lower. Then on the outside, you have the electrons. It's kind of like the solar system example. You got the sun in the middle and you got the orbits of the different planets. Well, that's sort of how like an atom is. It's got the nucleus where the neutrons and protons are. That would be like the sun. And then it has different orbits that go in them, but they're called orbitals. You'll learn more about that in high school when you take physical science and chemistry. And only so many electrons can be in each electron shell or orbital. And what happens is these electrons are going so fast that they actually form a electron cloud. It's kind of like the Flash, the superhero, the Flash. They kind of keep moving around and around and around, and they move so fast they make a cloud. Now, electrons is what causes things to combine. Um, what would happen is two elements, two atoms, they combine and react together because one takes one and one gives up one. And so they kind of share it. And that's how things actually react with each other and combine to form compounds. Now, it looks like that's the last one for this section, okay? Like I said, we talked about matter. Hope y'all have a good one. And that's pretty much it.